Picture this, a spaceship traveling at near light speed, powered by a fuel so explosive, a single gram could equal the energy of a nuclear bomb. Sounds like science fiction? That fuel actually exists. It's called antimatter. Antimatter is like the mirror twin of everything you see around you. For every particle of matter, there's an opposite. The electron has the positron, the proton has the antiproton. Same mass, but opposite electric charge. Together, they make up antimatter, a world of cosmic opposites. Now here's the wild part. When matter and antimatter meet, they don't bounce off each other. They annihilate, disappearing in a burst of pure energy. Imagine touching your reflection in a mirror, and both of you vanish in a flash of light. That's annihilation, and it's incredibly powerful. Just 1 gram of antimatter could release the same energy as a nuclear bomb. It is, without question, the most energetic substance we know of. But if antimatter is so powerful, where is it? Scientists believe that when the universe began, the Big Bang created equal amounts of matter and antimatter. Logically, they should have destroyed each other, leaving behind only light. But instead, we see a universe made almost entirely of matter. Stars, planets, galaxies, and even us. The question is, what happened to all the antimatter? This mystery is one of the greatest puzzles in modern physics. To hunt for answers, scientists turn to giant machines. At CERN in Switzerland, particle accelerators slam protons together at nearly the speed of light, creating tiny flashes of antimatter, particles like positrons and antiprotons. These experiments let scientists study antimatter for fractions of a second before it vanishes. But here's the catch. Producing antimatter is incredibly expensive. To create just 1 gram would cost trillions of dollars, making it the most expensive substance on Earth. So why bother? Because antimatter could unlock our future. In theory, antimatter could power spacecraft far faster than chemical rockets or even nuclear engines. A spacecraft fueled by antimatter could reach Mars in weeks instead of months, and maybe even take us to the stars. But there's a darker side too. If antimatter could be produced in large quantities, it could be weaponized, far more destructive than anything humanity has ever known. That's why antimatter research is carefully controlled, kept inside powerful magnetic traps, and studied under extreme safety conditions. Despite the challenges, antimatter is already part of our lives in small ways. Hospitals use positrons every day in PET scans, a medical imaging technique that relies on tiny amounts of antimatter to detect cancer and study brain activity. It's a reminder that even the strangest physics can have real benefits here on Earth. So what is antimatter really? It's a mirror twin, a cosmic eraser, a mystery older than the stars, a tool of healing, and maybe one day, the engine of interstellar travel. Humanity has only scratched the surface of what's possible. The question remains, will antimatter be our greatest discovery or our greatest danger? The future depends on how we choose to use it. Would you dare to hold the power of antimatter in your hands?